Let's start. Hello everyone, my name is Andrei Bériukhov, and today we are going to discuss 3 ways to try Kotlin multiplatform in your Android project. So first, let me introduce myself. I'm a senior Android engineer at Villi. We have an office in Nicosia. And also I had an experience with lots of Russian articles and speeches about Android, Compose, and also Kotlin multiplatform starting from the beginning, from 2018. And I've tried to reflect all these article speeches in my pet project, where you can find some code samples. Today, our talk will consist of 4 parts. So first of all, we will briefly talk about problem and solution Kotlin multiplatform helps you to solve. Next, we will discuss 3 ways to try it. It is about a separate library, about a product feature, and also about gradual migration by chip changes. So let's start with problem and solution. Before 2017, mostly we had a very large popularity of native development. So we had native Android and native iOS development, and not very popular some cross-platform solutions. Most important them each React Native, which wasn't better that years, and it still has no version with number 1 before the point. And also some exotic approaches like JavaScript based, it's Cordova, Ionic, and so on. Also, some companies used C# and Xamarin for their applications development. And the last one is a class of C++ based approaches. For example, using some shared library with business logic, which then compiles into SO or DLL. And also some companies also try to share UI with Qt, for example. And why these 2 are present in our presentation is that, in my opinion, they caused a very strong prejudice that cross-platform will never succeed and will never make applications same as native one, same performance, same native looking, and so on. And for me and for others, probably it was always obvious that we could try some code reuse. It's very strange that we need to write same business logic, same code twice for both Android and iOS. And if we could reuse some parts of them, we could receive same logic. And because of this cheaper app development, with Kotlin multiplatform, we already have some numbers. So we can save from 20 to 40% on app developments. We could align some resources between platforms. For example, in previews, when your Android application developer is on vacation, the Android application development is stopped and iOS going forward. And now we can try to utilize some T-shaping of them. So in terms of the vacation, second developer could try to write some common code. And after vacation, they will together write some native binding over them. And the third one is less differences bugs. What do I mean? Whenever you're trying to make same 2 applications, there are some edge cases, there are some bugs that one developer finds and another didn't find and didn't ask about it from other developer, and so on and so on. And it's always 2 apps looking a bit different or have a bit different business logic inside. So with common code, we obviously can solve this problem. And the reason why we talked about 2017 is that next year, 2018, we got 2 frameworks for cross-platform development, 2 new frameworks. First of them is Flutter, which allows us to share UI from the beginning, and we will not talk about it today. And second one is Kotlin multiplatform, which allows not only share logic between client platforms such as Android, iOS, desktop, web, and so on, but also try reuse some code with server if it is JVM based. Today, we will focus on 2 mobile platforms, Android and iOS, and talk mostly about them. But before we start, let's introduce some terminology. What do we mean when we talk about Kotlin multiplatform, or KMP? It is a technology that consists of 4 parts. So it's Kotlin compiler, it's some build tool plugin, for example, Gradle on U1 Ampere. It's also mechanism of source sets and an IDE tooling, IDE plugin. So it allows us to share business logic written on Kotlin between separate platforms. And if we are looking on the application as a layered, in layers, we are talking here about 3 layers of 4. So we are not talking about sharing UI with Kotlin multiplatform, but we will talk about sharing the UI with Compose multiplatform, which we will name also KMP. It is a technology that is based on Kotlin multiplatform and Android Jetpack Compose, and it allows us to share UI, also written on Kotlin, also between same platforms. And both of these technologies had an interop in design from the beginning. So for KMP and Android, it gives us the same JVM bytecode as without KMP. And talking about iOS, it gives us, it compiles into native binaries, also known as frameworks, with some Objective-C headers. These Objective-C headers can be easily called from Swift code, but we also waiting for Swift interop in the nearest future, a direct Swift interop, which will be much more convenient for iOS developers. Also, in comparison to Flutter, for example, it has no virtual machines. It don't bring them itself into binary. It gives us less size of this binary and less performance overhead. And last one, we have a convenient expect actual mechanism that allows to share most of the code and only write the code which needs to be written in native platforms in very convenient way. Talking about Compose multiplatform interop, also it is same engine as native for Android, same as Jetpack Compose. It even has the same imports with Jetpack Compose. So when you are migrating, you only need to include other libraries, and all will work almost the same as before. It is really important because if you are using some UI test frameworks which are based on Jetpack Compose, they are compatible with Compose multiplatform in Android. And for iOS, it is important for us that it consists of 2 major parts. So first of them is Skika library, which allows to render some views on Canvas, and it is an only platform-specific part. And the second part is the number of widgets, renderers, state handlers logic, which is the same in Jetpack Compose and works the same as in Android, as in desktop, WASM, and so on. And it is really useful when you have the same design system in Android and iOS, same looking, but also some details possible. Also, it has an interop with native UI toolkits, such as UIKit and SwiftUI, both, and you can use them in both ways. So you can put Compose multiplatform code inside UIKit and SwiftUI, and vice versa. To finish this part of presentation, I would like to share with you my observations. So first of them is that Kotlin multiplatform went from is it worth trying phase to how start adopt. So previously I've seen a lot of articles, a lot of speeches of comparison Kotlin multiplatform with Flutter, React Native, and so on. And now I see more and more articles about how to start adopt, how to architecture your application, and so on. And the second observation is that the challenge of introducing KMP into your project is split it on 2 parts, almost equal. So first part is related to technical specificities, such as how to configure your build, how to configure your repository, how to configure your code, and so on. And the second part is almost the same. So you need to technically approve this technology with your team, with your iOS developers and with your stakeholders to ensure them that it is safe, that it is useful in your project, and so on. And that iOS developers will need to know Kotlin also. Let's move to the next part. So from now, we will start talking about each of 3 ways to using KMP. We will talk about some use cases, and we will talk about the benefits and consequences. Before Cyprus, I was working in Avito. It's a Russian classified, probably you know. And first use case is related with it. So my colleagues previously wrapped external C++ library with simple contract. So they wanted to make video calls feature, and they tried to use WebRTC for that. It has a really strong contract, lots of logic to be needed to be written around it. And so they made a mobile SDK where they written all the logic around WebRTC and gave the determined contract into the native application. So this library, together with WebRTC, was included into native applications as some other external SDK, and also it had a separate repository, which is important when you have 17 developers for a platform, for example. Another use case was recently mentioned also on JetBrains case studies website. It's about Yandex, which uses Kotlin multiplatform in several of their applications, mostly in disk and maps apps. And in these applications, they already tried to share business logic between their platforms. So they made it with C++ library. And later, when KMP appeared, they just tried to replace it with Kotlin multiplatform. And they continued to doing it because it's obvious that for mobile developers, it's much more easier to write Kotlin code than C++ code. Third use case I would like to share with you today is related to reusing remote contract between client and backend. Here, the use case from OK, it's a video player, and they started to adopt KMP with sharing the only one complex entity. So they have the one entity which had hundreds of fields, which was rapidly developed and changed, and they tried to make it same on all of their platforms, including not only Android and iOS, but also Smart TV and web from platform side and backend on backend. So here is a link on the talk about how they made it, but it also a very nice use case for starting from something small but important in your application. So let's talk about benefits. First of all, it's a separate repository. It means that you can start with low knowledge about Kotlin multiplatform. You will not probably interfere into the process of development of most of your applications. It's easy to start because of low coupling with this application and have minimum risks. Also, it has separate dev cycle, so you can release it whenever you are ready and not needed to run with all other parts of your application. About consequences, it has the same root, so it's a separate repository with its own lifecycle, and you need to synchronize it with main code. So probably for new features, you will make 3 pull requests in common code, in iOS code, in Android code. And also, because of the isolation, you isolate team expertise. So other team members are not ready to scale this experience in other parts of the application. And because of that, it also could have low effect on the main project areas. It means that in this library, you probably making something not very important from the beginning, but you are developing more rapid developed parts of the application are still developed in native. I would like to recommend there the TouchLab article on this topic of scaling and problems of scaling KMP in teams. It's really nice explaining these consequences, and I very liked it. I've translated it to Haber. So let's move on to the second approach, which differs from the separate library. It means using KMP in a whole product feature. Talking about use cases, we have 2 of them here. First of all is to create a new feature. It can be built as a usual Android feature model, but with later adoption in iOS. And another use case is to replace already existing native feature in two applications with one common Kotlin multiplatform code, and to start developing it from there in a common code. Previously, I had a speech related to this topic about scalability of Kotlin multiplatform on a feature in a big project, and I recommend you to watch it. And the main outcome and main update after the speech is that we replaced the native implementation of the feature with Kotlin multiplatform, and checked in A/B test on production on real users the performance of iOS. We were expecting, colleagues were expecting that it could have some performance outcomes, but it has the same performance and gray A/B test. Talking about product feature and what are the changes in comparison to library. So let's imagine that typically product feature has all the layers in terms of clean architecture or any other architecture analog, and it contains UI, it contains some view logic, it contains some domain logic, and also some code related to data keeping in database, in network, and so on. And why library is highly isolated from the rest of the project, product feature usually depends on some of your platform libraries of your application. So it means using some UI architecture, using some engines for analytics and performance metrics, using some deep link handler or navigation, some DI, some common parts of network, such as sessions, authorization, and so on. And to adopt product feature in KMP, you need firstly adopt most of this platform feature in KMP as well. And you can make it with two ways. So one of them is obviously migrate these libraries into KMP, but it's harder way. And another way, you can wrap them with adapter, wrap native implementation with common KMP adapter, and use them in this way in your KMP code later. In my experience, we've tried both of these approaches, and it works. It really works. It helped us to migrate these platform libraries for the product feature. And with product feature, we can share most of the code related to it, except for UI. So UI we left native in Swift UI and Jetpack Compose, and all other parts we can share in KMP, including view models, including obviously business logic, and so on. Let's discuss pros and cons of this approach. So first of all, because you are doing a product feature, you have a visible impact and scalability. Visible impact because you are making something UI related or something similar to what you are doing usually with your applications. And scalability because other developers can see what you made with your feature and make the same with their features to reuse their libraries you migrated before. Also, lifecycle can be common with Android or iOS repositories. So you can put, for example, KMP code into your Android monorepo and only include it to iOS monorepo. So you have at least one pull request less than in previous approach. And last one is that by developing product feature in KMP, you can gradually migrate other core libraries of your application, other platform features as well. So you can start from the small product feature which has less dependencies on these libraries and to continue evolving, introducing new core libraries in KMP. About consequences of this approach. So it needs already some of your expertise in KMP before. So otherwise, you can break your builds for your teammates who are working with native repositories. You can introduce some bugs you've never met before, but it becomes easier with tooling of KMP. Next one, you need obviously a preparation of your core models and libraries before starting this product feature. And last one, you need to plan for approval with management and iOS team because it makes more changes in your application development lifecycle. And talking about these two approaches, two ways of using KMP are sort of analog as working in office as we made before COVID. So one of the teams, one part of teams was working in a closed offices, closed cabinets, and others didn't know probably what they are doing. Only expertise of this team was concentrated in this office. And in comparison, in open space, you probably know what your colleague does. You probably can ask some question how he or she does it and try to using something like this. So this is an analog of product feature approach when it is easier to repeat another next product feature made in KMP after first one was made. And the third way I want to share with you today is gradual migration in Android project by chip changes. This is the way we are trying now in our Willy applications. So Willy is a ride-hailing product. We focus on a smooth mobile experience and makes for this currently two applications, one for passengers and one for chauffeurs, and each of them have native Android and iOS versions. So once again, what we are making is a gradual migration in Android code base in Android monorepo by chip changes, and we expect this to lead us to KMP future. So let's talk about these chip changes. First one is related to architecture. Before we started, we had already almost 100% Kotlin code base. We have custom DI without capped. We have custom Redux architecture, also pure Kotlin. And that's why my colleagues previously extracted some platform-independent code. So they made core libraries, they split it into two parts. First one, core, is contains all the platform-independent code, and second one, core Android, depends code which Android dependent. And I've seen the opportunity here to use some Kotlin compiler checks with using structure of cross-platform module. So I've used cross-platform source sets for splitting these parts of code into single module. So first source set is Android main, was previously a core Android, and common main was previously core. And when I was migrating to it, I've noticed that in real life, core was not really platform independent, and core Android had some code that could be moved to platform independent part. And here, the Kotlin compiler now allows us to check it in compile time. Second chip change is related to libraries. So while doing our code base more modern, we looking into libraries and if they have their KMP versions. So it is easier nowadays to make because Google Jetpack libraries provides more and more KMP support. And one of these libraries recently become Room. So we replaced our previous library for working with database ORM Lite, which were Java based, which was the cause why we left some of Java code in our repository. We migrated from it to Room. We removed all our Java code, and we use Room in a KMP module since we using it only in Android, but we already ready to be used in iOS code as well. Another example is JSON. It is a library for parsing JSONs. And it is also Java-based and using Java reflection, and that's why it doesn't know nothing about nullability of Kotlin. So we had surprises after parsing when JSON could parse null values into not nullable fields and blast it somewhere in runtime in the business logic with null pointer exceptions. So that was the main reason why we changed it to Kotlin serialization, but as a additional benefit, serialization obviously supports Kotlin multiplatform as well. And last one, chip change, is related to Compose, to our UI. So we recently started to create a Compose UI kit and to migrate some screens on it. And also it is important for us, and why we made such a decision, that we have custom design system, which looks the same in Android and iOS. And it doesn't depend on Material library or Cupertino iOS library. And we decided to try Compose multiplatform here. So yet we are using it in Android production builds, but we made an iOS demo application where we collect ready features and showcases with this new UI. And also iOS demo application allowed us to check that KMP modules are truly multi-platform, because before we introduced iOS targeting core module, compiler allowed us to compile Java code inside the common source set. Let's finish by discussing the pros and cons of this approach. So first of all, it is safe because it works the same in Android, and we are using still it for Android. It is almost free because we are targeting on refactoring of our application most rather than migrating to a KMP. So KMP is a side benefit here. And last one is that we, in some future, will be ready for possible business needs, such as making new huge feature in both application or making a new application. And we could start try it with already ready Kotlin multiplatform libraries or Compose multiplatform UI elements. From the consequences side, it should be rather obvious. So first of all, we have no final result goal and focus. So in comparison to library creation or product feature creation, when you focus on making something complete, you may cut some edges to run faster, to make more and more for this feature. But in this case, we are just taking the cheap changes, taking the low fruits, and using KMP for that. And second one should be also obvious because of we don't using KMP in iOS. For now, it has less benefits in comparison to if we already used it for second application. So second application is still native. So just to sum up, we are taking a look on 3 ways of using Kotlin multiplatform in your project. First of all, I would recommend you, if you never met KMP before, to try write some small application, some small pet project, and after it to choose how to use it in your production application. And you can choose from separate library, from product feature, and use some experience you had with separate library. Or if you are not planning to use it in iOS, you can just gradually migrate your Android repository with cheap changes. So that's the final slide. All the links are compiled in this QR code, and I'm ready to answer your questions.
Yeah, let's go try to use Nick.
This is the way of.
Yeah. What?
No. Why it's not working?
Yeah, it's working.
Yeah, very good presentation. It's nice to see that more and more people use KMP. And question is about iOS. So what starting position do you have when it comes to architecture in iOS? So do you think it's easy to migrate to the style models also?
Very common answer would be it depends. So it depends on the project you are starting with. In my current project in Vili, we haven't looked into what iOS has now. So we are just working with our Android code base. And in previous experience, we didn't this product feature, we didn't depend on the iOS architecture because we just supplied them with a small interface like MVI architecture does, so with actions, with state, and they've subscribed to it in their Swift UI code, and it didn't interfere somehow with their current UI architecture and current architecture of their models.
Thank you very much. More questions? Thank you for your presentation. My question is, how many modules and skills do you have been improving with platform module?
Current project has 25 models at all, and from them, multi-platform are probably a half. So we recently started this way. We started from core models. We started with UI compose models and related stuff. So our application models are still native, of course, and we have not so much feature models for gradual migration of them. I suppose we will move in this direction.
And I the second question. What was the reaction of your iOS developer who is us?
I was preparing to it, so before I started talking with them, I've prepared the iOS demo app, and I prepared it 3 days ago, so they didn't see it for now. But in previous company, iOS reaction was very hard, and that's why I mentioned several times that you need some plan to prepare your iOS developers. So my attempt is to try show them iOS demo app to see for them to see how it works, how it is native looking, and so on. And maybe it will help to easier accept these changes.
Thank you. Hello. Could you tell about unit tests, please? Which platform do you use for running unit tests? Maybe do you have some problems with mocking? Which library do you use for mocking?
So for unit test, there are plenty of libraries. So I suppose it's Kotlin test, which is similar by syntaxes as well for JUnit, and it depends on the unit under the hood. So we run Kotlin test. We run tests in Android related to unit tests. That's all. We had not very much experience with unit tests, or some problem with there, but just migrated for core libraries the unit test to Kotlin test, and it worked, and mock-k about mocking library.
Yes, in my experience, I also use mock-k, but mock-k doesn't support Kotlin multiplatform, and I need to buy unit test in Android project or Kotlin multiplatform code.
It's interesting experience.
Yeah.
Let's discuss after.
Thank you.
Third, thank you very much for the really complex presentation with a lot of linked materials. So my question is really easy. Which steps will be next in your adaptation process? So maybe it will be another presentation, but anyway.
Yes, so the closest step is to complete the iOS demo application with more showcases, and to show it to iOS developers and to our stakeholders. Also, while driving today from Nicosia to Limassol, we already talked more with my team lead, Andrei team lead, about next steps, and he suggested, Kirill, he suggested to move one of our additional core libraries, which is also C++ based, to Kotlin multiplatform, and it is already used in iOS, and probably it will be easier to make changes from there and introduce KMP as a Trojan horse with this library.
Yeah, thank you very much.
Thank you.
Any more questions? Oh, I want to ask one question. By the way, which language do you use for backend side development?
Not actually not. We are using Golang and some pieces of Ruby. In previous project, we also had Golang, so we have no opportunity here to share some Kotlin models with backend.
Maybe more questions. It's excellent example how we use KMT in real project. Amazing. Questions? No? If no questions, one more time. Andrei, thank you for amazing keynote. Yeah. And what's the questions in your heart?
In my heart is question about iOS developers and their attitude to all of this stuff. It's almost it is every speech I've made.
You remember who asking this? Yeah, congratulations. Also, one more key for the year. Yeah. If you wanna.
Thank you. Thank you.
Yeah. For now, we finish, but also we have a lot of beer, food, and make after party.